In this part, we will deal with problem 3 for designing the pre-draining border irrigation, and we will calculate the parameters for the border irrigation design in this problem as follows. This data describe a 133,000 and 614 meter field supplied by a well with a capacity of 283.33 liters per second. The soil is a clay but with an average 6-hour intake rate of 0.54 inch per hour, in part because the cracking components. The field is currently irrigated as a free draining border using 366 meter runs and unit flow of 3.69 liters per second. The inflow is cut off at 4 hours, and before the end of the advanced phase, the resulting application efficiency is 69%. This field has a grass surface which is described by Manning N value of 0.18 during both initial and later irrigation. From two-point field calculation, we have TL equal 276 minutes and T.5L equal 125.5 minutes. These are the data of the third problem related to the border irrigation design, and based on these data we will design the border irrigation as follows. Solution. And field width for one irrigation equal total discharge over discharge per unit width, which equal 283.33 over 3.69, which equal 76 meter. Total field width equal total field area over border length, which equal 133,614 over 366, which equal 365 meter. Border area equal field width for one irrigation multiplied by border length, which equal 76 multiply 366, which equal 27,816 meter square. Then volume of water that applied to border equal total discharge multiply cutoff time, which equal 283.33 over 1000 multiply 4 multiply 3,600
which equal 480 meter cube.
Cross depth of irrigation (GDI) is equal volume of water that applied to border over border area, which equal 4080 over 27,000 and 816, which equal 0.146 meter, which equal 14.6 centimeter, and maximum depth of flow in the border equal cross depth of irrigation minus 5 cm, which equal 14.6 minus 5, which equal 10 cm, and the average depth of flow in the border equal max depth multiply 0.8, which equal 10 multiply 0.8, which equal 8 cm. Then net depth of irrigation NDI equal cross depth of irrigation GDI multiply application efficiency, which equal 14.6 multiply 0.69, which equal 10 centimeter. Then we go on manual calculator and NRCS surface. We input the following: and now one Manning N from table 0.18.
We go to the NRCS surface program, then we press on the design menu, then in the units menu we choose metric, then we go to the infiltration characteristics menu, and in it, in the units of measures we choose metric, then we go to the field topography over geometry menu, and in it, in the field system we choose border over basin irrigation, and the unit width is 1 meter. Then in the downstream boundary we choose the free draining. Then in the Manning end values we type 0.18. For the first irrigations and for the latter irrigations. Then in the flow cross section we specify the options as we see. Then we go to the Manning equation calculator, and in it we input the Manning N, which is 0.18. Then in the inflow in liter per second we choose the unit flow, which is 3.69 liter per second. Then by trial and error we input the value of slope that gave us the average depth of flow in the border 8 centimeter as follows as we see. Finally, the value of a slope that gave us the average depth of flow in the border 8 cm is 0.002.
Then the value of a slope equal 0.002. Then the border width from table هنا عندنا table recommended maximum border strip width irrigation grade with maximum strip irrigation.
And as we see for this range, the maximum strip width in meter is 18 meter. Then the border width from the table equal 18 meter. The number of borders for one irrigation equal field width for one irrigation over border width, which equal 76 over 18, which equal 4. The total number of borders equal total field width over border width, which equal 365 over 18, which equal 20. Z-trig equal net depth of irrigation NDI over unit width. The Z-trig is extracted on the volumetric basis, which equal 10 over 100, which equal 0.1. Then we go to the NRCS surface program. Now, after we had made the calculations for the border irrigation, we input the data and parameters for problem 3 for designing the border irrigation. In this part, we contend by making these calculations for the field or border dimensions, and we will input the data and parameters of the border irrigation dimension for problem 3 for designing the border irrigation in the NRCS surface program in the next parts.